So you've probably been there. You build a retrieval augmented generation system, a array system. You feed it your documents, hook it up to an AI, and you watch it answer questions. It feels pretty empowering at first, doesn't it? You probably have that moment of pride, maybe for a day or two, but then that little worry starts to creep in. Can you actually, trust what the AI is telling you? Can you prove where that information came from? Can you see the exact source, a specific document, page number, maybe a timestamp? If the answer is no, then, well, what you've built isn't really an intelligent system. It's more like a fancy magic 8 ball. It might give you the right answer, or it might be confidently hallucinating. You just have no way of knowing. And in business, flying blind like that, that's how you crash.
And that is exactly what we're here to fix today. Welcome to the Deep Dive. We unpack the core problems holding back AI systems that are, genuinely useful. Today, we're going deep on a concept that sounds simple but is incredibly powerful: metadata. It's really the key ingredient that turns your RI system from this kind of untrustworthy black box into something transparent, auditable, and, well, actually useful.
Mm-hmm. Our mission today is pretty clear then. We want to move beyond that magic 8 ball stage. We'll show you how to build an AI system that isn't just smart, but one you can rely on, one you can trust.
Absolutely. We're going to start by really digging into why these RE systems sometimes struggle to earn your trust. It's a common problem. Then we'll peel back the layers on what metadata really is and why it's so often overlooked or misunderstood. Next up, a practical blueprint. How do you actually build a metadata-rich system from the ground up? We'll explore some advanced uses too, might surprise you. And finally, highlight some common pitfalls. Easy traps to fall into. Let's get into it.
When Eric first appeared, there was this definite sense of possibility, wasn't there?
Okay.
You give it your data, ask a question, and poof, an answer appears. Magic. But that initial wonder, it pretty quickly gives way to a kind of trust crisis. Everyone knows AI can write things, make images, even code now. But the real hurdle, trust. There's just so much AI-generated stuff out there. It's getting harder and harder to know what's real and what's
Yeah.
just made up.
This really is the new frontier. The next generation of valuable AI systems, they won't be defined just by creativity or raw intelligence. It's going to be trustworthiness.
Yeah.
And that brings us right to the aha moment. So imagine an advanced RA agent. Let's say it's trained specifically on dozens of YouTube video transcripts. You ask it something complex like, what's the real difference between a relational database and a vector database? It doesn't just spit out an answer. It gives you evidence.
That's the crucial difference, isn't it? Instead of just a summary, you get an answer. But with sources, you can actually check. It's like your smart assistant isn't just telling you something, it's handing you the book and saying, look, here's the page you need.
Exactly. The final output from a system like this looks more like this. In summary, relational databases store structured data in tables, fixed schemas, complex queries. Vector databases store high-dimensional vector data. Focus on similarity search. You get the idea. But then it adds, I found this information in the video. What are vector databases? Pros and cons versus relational databases at timestamp 000.37. You can watch the full explanation here, and then a clickable YouTube link.
And that's why metadata is so powerful. It genuinely transforms your AI from maybe a fun toy into a proper tool. Without it, you get an answer. With it, you get an answer you can absolutely trust. So what's the core issue if we can't verify an AI's source?
Well, without provenance, AI is just a black box. Trust completely collapses. Okay, let's talk metadata. What is it really? Simply put, it's just data about data. It's extra info that tells you where something came from, what it's about. It doesn't change the actual content, but it adds that crucial context and understanding.
And here's a really common mistake people make building RV systems. They focus only on the main text chunks, the actual words, and they completely forget these critical extra details. It's like trying to navigate a huge library. But there are no labels on the shelves, no labels on the books. You just can't find anything reliably. It makes your whole knowledge base way less useful than it could be.
That's so true. Good metadata, though, it looks really specific depending on the content. For YouTube videos, you want the video title, channel name, upload date, those precise timestamp ranges, the video URL definitely. For business docs, think title, author, department, creation date, file type, maybe even version number, customer support tickets, ticket ID, customer name, issue category, resolution status, the agent involved. It doesn't change how the AI reads the text itself. It changes how you can use it and, crucially, trust it.
Right. And taking this metadata-first approach gives your RG system 3 immediate superpowers right off the bat.
Oh yeah, these are the good ones. First up, provenance and trust. We call this the show your work power. This isn't just about checking sources. It's about changing AI from some mysterious black box into a transparent partner you can actually hold accountable. That's non-negotiable for business use, for compliance. When your AI gives an answer, you can instantly check its source. No more wondering, did it just make that up?
Oh, wow.
You provide direct links. That builds a level of trust a black box system just can't match. Second superpower, organization and segmentation, the chunk power. Instead of this giant messy data swamp with like a million text chunks all jumbled together, metadata brings order. It turns that swamp into an organized library you can actually navigate. Clear sections for departments, document types, time periods. And third, precision filtering, our sniper rifle power. This is where it gets really cool. Sometimes you don't want to search everything, right? Metadata filtering lets you be surgical. You can tell your agent, search only through marketing documents created last quarter and give me the key takeaways. That level of precision.
It turns a simple search tool into a seriously powerful analytical instrument. So why is metadata crucial beyond just finding information?
It's fundamental. It builds user trust and enables that precise organization you need.
Okay, let's get practical now. Let's unpack this. This isn't just theory. It's really a blueprint for building a metadata-rich RAG pipeline. And it all starts with a basic truth. Good answers only come from good, well-organized data.
Precisely. Step one is what we call smart ingestion. It's all about preserving your data's DNA, its context. For our YouTube example, the process kicks off when you provide the video's title and URL. That's the trigger. From there, an NNN workflow that's a powerful low-code automation platform just takes over.
Right, so phase one is gathering the raw evidence, scraping the transcript. The workflow uses a tool, maybe Appify, it's a web scraping platform, to go to that YouTube URL and grab the full transcript. But here's the catch, the data you get back. It's not simple or clean. It usually comes in hundreds of little pieces. Each piece might only have a few words, a start time, a duration. It's messy. Yeah, and here's where most people make their first big mistake. You see this fragmented mess, and their first instinct is, okay, let's clean this up. Combine all these tiny text snippets into one long transcript. You can do that easily with a bit of code. But the problem, you lose all the timestamped information when you do that. It's like throwing all your crime scene clues into one box without labels. You don't know which clue relates to what anymore. Your data just became effectively dumb.
A professional approach builds differently. Instead of destroying that context, we preserve it carefully. The goal is to create meaningful chunks of text, but keep that timestamp data perfectly attached to each one. And this is often done with a clever code node that acts kind of like a meticulous forensic investigator.
Exactly. It groups the evidence. It loops through maybe hundreds of these tiny transcript objects. It groups them into logical chunks, let's say, 20 objects at a time, which might be about 40 seconds of video. Then it builds the text by combining the words from those 20 objects into a coherent paragraph. And crucially, it bags and tags the evidence. For each new paragraph, it tags it with metadata. It grabs the start timestamp from the very first object in that group, calculates the end timestamp from the last one. It packages that text paragraph and its start to end timestamps together into a single smart chunk, a rich data packet.
So every single piece of information you're about to file away in your database is now perfectly labeled with its origin. The evidence is bagged, tagged, ready for the library. Taking that care now really helps your AI give trustworthy answers later. So the key is keeping that source data connected to the chunks, right?
Absolutely. Preserving that context is what prevents creating dumb data.
Right.
Okay, once you've ingested the data smartly, the hard part is kind of done. Step two is metadata enrichment. Think of it as creating the digital card catalog for your library as we store each chunk in our vector database. Supabase is great for this, built on PostgreSQL. We don't just save the text in its vector embedding. We attach that rich set of metadata fields we just preserved. It's a fairly simple step, just mapping the preserved data to the metadata column in the database.
Right. So the final data object for each chunk looks something like, open curly brace, video title, colon, tips for building AI agents, comma, timestamp, colon, 12.3, 13.9, comma, video URL, colon, https.youtube.com, watch.v example. Close curly brace. It's clean, it's concise, and it's packed with context.
And here's a really crucial insight. Metadata is the salt, not the steak. This is probably one of the most important and commonly misunderstood things in building RAG systems. This metadata, it has zero effect on the vector calculation itself. Think about it like this. The content of your junk, that's the steak. That's the core substance. The AI analyzes the steak itself, its texture, its quality to decide where it fits in the semantic universe. The metadata, that's the salt you sprinkle on top after it's cooked. Salt doesn't change the steak itself, but it enhances the flavor, tells you maybe where it came from, who cooked it. When a user searches, the AI first finds the most semantically relevant text chunk, the best steak. Then it looks at the salt, the metadata, to tell you where that steak came from.
Which brings us neatly to step 3, smart retrieval and display. This is the show your work payoff. This is really the moment of truth. The library is built, the books are on the shelves, the card catalog is complete. Now a user walks up to the front desk and asks our AI scholar a tough question.
Right? The process looks kind of like this. User asks a question, maybe, what are the key takeaways about that new AI tool? That question gets translated into a vector for comparison. The system searches the vector database for chunks most similar to the question vector. Then, often there's an "are you sure?" check re-ranking. It might find, say, 10 possible answers and then sort them again to find the best 2 or 3 results. Finally, the AI does synthesis and citation. It uses those best 2-3 chunks to write a fresh answer, always adding the metadata, like the source information, to that final output.
And the result is a genuinely trustworthy answer. Instead of just a simple paragraph you can't verify, the user gets something more like this. The key takeaways about the new AI tool from OpenAI are: the AI features an incredibly realistic voice. Sounds exactly like a real human. Breathing, whispering, even singing. It can perform tasks like singing happy birthday in a very human-like way. The realism raises questions about how human-like AI should be, getting a little bit too human-like almost. And then the citation. AI is taking over, and it's getting real scary this time. 019, 0.53, 2.39, 3.23. Watch your clickable YouTube link. It clearly shows the significant progress, but also flags the source.
This is the end game. This is what it looks like when an AI doesn't just give you an answer, but gives you the evidence. Your users can trust your AI because it always shows its proof. It's a system that basically says, hey, don't just take my word for it. Here are the receipts.
Right.
So what's the main benefit of actually showing the source like that?
It builds that verifiable trust and really empowers users to check for themselves. Mid-roll sponsor read. Okay, now let's talk about what might be the ultimate power move here. Metadata filtering. This technique, I think, truly separates the professional-grade systems from more amateur projects. It's where the real precision, the real targeting comes into play. Here's where it gets really interesting.
Right. So far, we've mostly talked about searching, well, everything. It's like going to that huge library and asking the librarian for just a book on ancient Rome.
Yeah.
They might bring you back 100 different books. You'd have to sift through them all. But what if you could be more specific? What if you could say, go to the ancient Rome section, but only bring me books written by Mary Beard and only those published after 2010? That, my friend, is metadata filtering. It lets you search just the specific slice of your library you actually need.
And how it works, technically, you build a user interface, maybe a simple form in your app, that lets the user specify not just their question, but also the context. For our YouTube example, the interface might have 2 fields, maybe a drop-down menu to select a specific YouTube video title .type, and a text box for their question. When the user hits submit, the NAN workflow gets both pieces of info. In the background, the command it sends to the Supabase database isn't just find text similar to this question anymore. It's now find text similar to this question where the video title and the metadata equals AI is taking over, and it's getting real scary this time. That simple where clause, it completely changes the game. Now the agent searches only one specific document or video, makes the answer much, much more focused.
Yes, exactly. So for a user's filtered query like, okay, I only want to look through the AI is taking over video. Give me the 3 key takeaways from that video specifically. The system, using that metadata filter, totally ignores all the other videos in the database. Zero confusion. It responds with insights pulled exclusively from that one source, complete with specific timestamps for each point, because it knows with 100% certainty the information came from that exact video.
And then you get the pro-level upgrade. Multi-filter power searches. With metadata filters, your RJ system can search with incredible accuracy, almost like a seasoned data analyst. Imagine a knowledge base for a large company. Metadata for department, document type, creation by date. A manager could ask something like, what was our stated marketing budget for the last quarter? Search only in documents from the finance department that are tight quarterly report and were created in the last 12 months. Whoa, imagine scaling that. 1 billion queries like that, that's a level of precision. It turns a simple search tool into a really powerful analytical instrument. So how does filtering fundamentally transform ARG agent?
It lets it perform precise, targeted research, almost like a dedicated data analyst.
Now, while the rest of the world is often focused on the flashy generation part of AI, the true professionals are thinking about the, let's be honest, unglamorous but absolutely essential work of maintenance. You have to have a system for removing outdated or irrelevant content from your vector database. Otherwise, you risk what some call AI brain rot. Carolyn, your agent starts giving customers old pricing, citing policies you don't even have anymore, referencing discontinued features. This can seriously hurt your business. It just erodes trust completely.
Totally. And the answer is to build an automated system that cleans out that old or bad data. And you can do this with something as honestly simple and brilliant as a Google Sheet acting as your control panel. This creates a really simple, non-technical interface that anyone on your team can use. They don't need to know ME or Supabase. The setup's pretty straightforward. Every time your R-Edge pipeline processes a new video or document, it adds a new row to this Google Sheet, tracking key info like video title, video URL, and a status column initially set to active.
Okay, now you build a separate, dedicated N8N workflow just for this housekeeping. The trigger. It starts with a Google Sheet trigger node, set up to watch that status column and run instantly whenever a row there gets updated. The filter. To start a deletion, a team member just changes a video status in the sheet from active to remove. That change triggers the workflow. A filter node then checks, is the new status actually remove? The deletion. If yes, the workflow moves to a Supabase node configured for a delete operation. It uses the video URL from that Google Sheet row to find and delete all the vector chunks in your database that have a matching video URL in their metadata. Gone. The confirmation. Once that's successful, the final step updates the status back in the Google Sheet from removed to deleted, maybe adds a timestamp. Clean loop.
This simple automated loop keeps your AI's brain clean. It ensures outdated info gets purged from its memory, preventing it from ever giving a user a wrong answer based on old data. You know, I still wrestle with prompt drift myself sometimes, and honestly, the thought of this cleanup can feel daunting. But it's just so crucial for maintaining accuracy.
And for a pro-level upgrade, you could consider an automatic expiration date system. When you first ingest documents, maybe add an extra piece of metadata, a review date, say 6 months out from the creation date. Then you create another separate N8N workflow that just runs on a schedule maybe every Monday morning.
Yeah. And this workflow's only job is to scan your Supabase database and find any documents where that review date is now in the past. Expired content. For every piece it finds, it automatically changes its status in your Google Sheet control panel to something like needs review, and maybe even sends a notification Slack email to the content owner, hey, time to look at this again. This system proactively manages your AI knowledge, keeping it fresh, reliable, super smart. So why is automated cleanup so vital for maintaining AI trust?
It prevents that brain rot, ensures ongoing accuracy, and maintains overall system reliability. Okay, so the YouTube example we've used is just a simple demonstration, really. The real power of this metadata-first approach. It gets unlocked when you apply it to complex business data out in the real world.
Oh, absolutely. Imagine a customer support knowledge base, trained on thousands of past support tickets. Metadata for each chunk could include product category, issue severity, resolution date, supportage, maybe customer tier. Now, when a premium tier customer asks about a billing issue, the system can use metadata filtering to prioritize solutions that are recent, maybe came from your top agents, and are definitely relevant to premium customers. Big difference. Or think about a law firm. Metadata could be case type, jurisdiction, date filed, court level outcome. A lawyer could then do an incredibly powerful search like find precedents related to intellectual property disputes in California at the appellate court level where the outcome was summary judgment. That kind of research normally takes a paralegal hours. Now, seconds.
Yeah, or even for just an internal company wiki. Metadata could include department, document type like policy, tutorial, meeting notes, last updated date, author. An employee in marketing could ask, what's our policy on social media engagement? The system could filter to show only official documents for marketing, or maybe HR, updated in the last year, ensuring they get the correct, current info, not some old draft.
And if you're ready to actually build a system like this, the tech stack is surprisingly accessible these days. For the vector database, Supabase is a fantastic choice. Like we said, built on PostgreSQL. Solid. Aton is kind of the engine running the whole pipeline from ingestion to the interactive agent. For web content like those YouTube transcripts, Apify is a really reliable tool for scraping. And honestly, for many uses, Supabase's built-in similarity search functions are often powerful enough to act as your basic re-ranker. You might not need more.
When you're getting ready, here's a quick pre-flight checklist. Key configuration points to think about. First, chunk size. How big are your text chunks? It's critical. You need to experiment. Start with maybe around 40 seconds of video transcript or a few solid paragraphs of text and test what gives you the best results for your data.
Second, your metadata schema. Design this before you start building anything, seriously. A consistent schema across all your different content types is essential for that filtering to work effectively. Third, filtering syntax. Take a little time, learn your chosen vector database's specific metadata filtering syntax. It varies. This is the key to unlocking those power searches. And fourth, cleanup automation. Don't treat this as an add-on later. Build your automated housekeeping workflow from day one. A clean knowledge base is a trustworthy one.
Okay, let's quickly touch on some common mistakes. The things that often cause RAG projects to stumble or fail. Call them the four horsemen of RAG failure.
Yeah. First, treating metadata as an afterthought. So common. People get excited, build the ingestion pipeline first, then try to bolt on some metadata later. It's backwards. Design your metadata schema first. It dictates how your data needs to be structured and processed. Foundational. Second, over-indexing on chunk content. Yes, the content matters, obviously, but a perfectly chunked document with zero context. It's way less useful than slightly imperfect chunks that have rich, filterable metadata. Context is king. Third, ignoring data lineage. Every single piece of info in your vector database must be traceable back to its original source, period. If your AI gives an answer and you can't verify where it came from, you don't have an intelligence system. You've got a rumor mill. And fourth, using a static metadata schema. The info you need to track might change. Your business changes, your data changes. Build your system to be flexible so you can update or add to your metadata schema fairly easily down the road.
So what's the biggest takeaway for anyone building these systems?
Plan your metadata first. It's truly the foundation for building trust. Right. So let's bring it all back home. The bottom line here is metadata is the price of trust. The real difference between just a basic RAG system and one that's truly effective. It really is that simple: trust.
A system that just gives answers is, well, it's a black box. You can't see inside, you can't verify it. A system that gives answers and proves where they came from, that's transparent, it's auditable, it's genuinely useful. Metadata is the underlying technology that makes this transparency possible. It's the infrastructure of trust.
So if you're building a RAG system, your process should be really clear now. 1. Design your metadata schema first. Think hard about the context that will make your answers trustworthy and useful for your users. 2. Build your pipeline around that schema. Don't treat metadata like an afterthought. Make it core to the system. And 3. Always present the evidence. Make sure your final output includes the source. Allow users to verify the info for themselves. Empower them.
Stop building black boxes. Start building systems that people can actually rely on. Because in this new age of AI, the best system isn't going to be the one with the most data. It's the one that earns the most trust. Think about it. How do you verify information in your own daily life? Your AI should really be held to that same standard.
Thank you so much for joining us on this deep dive into RG systems and the real power of metadata. We really encourage you to explore these concepts further and start building AI systems that truly earn trust.
Until next time, outro music.